Are we sure? Maybe. You may have. Two. Oh, somebody's page is ripped off. Their back page. There should be 3 pages. So maybe that one got ripped off of this one. Okay. All right. So this section is going to start off, every chapter kind of starts off with stuff you've already seen before. Okay. So this first example here is starting off with things that you have seen before. Chapter 2 starts off with what's called inductive reasoning. Notice this section 1 is about inductive reasoning. We're going to talk about the definition of inductive reasoning. Then the rest of the chapter after 2:1 is going to be the opposite of inductive, which is deductive reasoning. And we're going to focus on deductive reasoning. We're going to, it's in the notes in just 1 minute, okay? But I'm going to show you what it is first. So find the next item in the pattern. Part of inductive reasoning is looking at a pattern and making a conclusion based on that pattern. So we have 7, then 14, then 21, then 28. What would come next? 35, okay? Most students can come up with the next number, but it's the next part that they may ask you on the homework to do, and that is to describe the pattern. This question doesn't say that, but your homework will say that on a lot of problems. Okay, so to describe, Edwin said, add 7 each time. Okay, and that would work. That would give us the next number each time. Or you could also say this is multiples of 7. So that's another way you could write it, multiples of 7. As long as your explanation explains to someone who doesn't know what the pattern is how to get the next term, it's valid. If somebody reads what you wrote and it does not adequately explain how to get the next number, then your description's not good enough. Okay?
Could you do like the thing where each one, like 7 is the first one, 14 is the second one? Like, could you do like 7 and then n?
So that's writing a rule for it, and we're going to talk about that later, but that is not what they're asking you to do here. So if it just says describe the pattern, it's not looking for a rule. If it wants you to write a rule, it will say write a rule for this sequence or series, okay? And we'll get to those. Okay, so moving on. They're not all going to be numbers. Sometimes they're geometric patterns. You have to find the next item, which means you're going to draw a picture. So we have a triangle here. What is the next triangle going to look like? Okay, so it's going to be facing the right, meaning that the point is going to the right. Okay, like that. Everybody agree? Okay, so again, describe it. What's the pattern? Rotate is a good word. Don't use turn. Good. Don't say left or right. Use clockwise or counterclockwise. So we're going to rotate 90 degrees counterclockwise. Okay, so I'm just trying to show you some good descriptions. Please understand, if the homework just says find the next item, then all you have to do is find the next item. But if it says describe the pattern, then you have to describe the pattern. Okay? Sometimes I would warn you, it's going to say find the next 2 items. So be careful that you've read your directions carefully or you'll miss part of your points on your homework. So if it says find the next 2 items, then make sure you list both. Okay. So now here's our definition for inductive reasoning. Inductive reasoning is the process of reasoning that a rule or statement is true because specific cases are true. That's the textbook definition. I always say inductive reasoning is based on patterns. So the way I can tell the difference between inductive and deductive is inductive is based on I can't make a conclusion until I've seen a pattern of events. For example, Edwin walks in wearing a white t-shirt today. Edwin walks in tomorrow wearing a white t-shirt. Edwin walks in on Thursday wearing a white t-shirt. Friday, we could conclude then Edwin's going to wear what? A white t-shirt. It's not a rule that Edwin wears a white t-shirt, but it's a pattern that we've observed, okay? So that's inductive. Inductive. Go ahead on your paper. We're going to write the definition for deductive. They'll talk about it in the next lesson, but let's go ahead and add it here. Deductive is not based on pattern. Deductive reasoning is a process of reasoning based on facts. Meaning it could be based on theorems, definitions, postulates, very good, etc. So it's rules. For example, our new tardy policy says that if you are tardy twice, the first time's a warning, the second time, what's going to happen to you? Lunch detention. You don't have to wait to see if that happens. That's the rule. So again, pay attention to the time, guys. You're at 6 minutes. When you come back, then you'll know kind of where you need to watch the video through. Okay, so based on facts is deductive. The majority of this course, we're going to be using deductive reasoning. We're going to have a theorem, a postulate, a definition, a fact, and we're going to make decisions based off our facts. We're not going to wait for a pattern to happen before we make a decision about what our answer is or what we should do, with the exception of this first section, which is about patterns and inductive reasoning, okay? But from then on, everything we do is going to be deductive. You can use inductive reasoning to draw a conclusion, like Edwin wears a white shirt to school every day. That would be our conjecture. A conjecture is simply a statement you believe to be true based on inductive reasoning. Okay? So a conjecture is a statement you believe to be true based on inductive reasoning. So my conjecture was Edwin wears a white shirt every day. Okay, it may be a true conjecture, maybe a false conjecture, but it's something that I made up based on my pattern. Does that make sense? Because you are going to have to write conjectures on your homework, and your conjecture will be a statement, so you'll be writing a sentence for your conjecture. Okay, so for example, we're going to complete some conjectures. Some of these will be easy, some of these will make you really think back to Algebra 1. Starting with the first one. The sum of two positive numbers is blank. Okay, positive number is what we should be looking for. The sum of two positive numbers. If you're not sure, make up some examples. Give me two positive numbers. 2 plus 2. Give me some different numbers. 9 plus 10. So we've got 4, we've got 19. So maybe you thought the sum is always even. Is that true? No. Maybe you thought the sum of two positive numbers is odd. Is that true? Not always. So the one thing that is always true is that the sum of two positive numbers will be positive. Okay, don't make this hard. Don't try to write me a paragraph. Just fill in the blank with a word. Okay? Don't make it too descriptive or too specific. Let's look at the next one. This one might require you to draw a picture. The number of lines that are formed by 4 points, no 3 of which are collinear. Okay, so first of all, it takes you back to last chapter. What does collinear mean? On the same line. So no 3 can be on the same line. But you have 4 points. 3 of them can't be on the same line. So that means you could have one here, you could have one here, but you can't have one here. So you got to move it somewhere else. Okay, and then we need another point. Doesn't matter where. It just said 4 points. You're supposed to fill in the blank. The number of lines formed by 4 points is what? So you decide, how many lines do you think you can form out of those 4 points? Or any 4 points, as long as you don't have 3 in a row. Start taking some guesses. What do you think? 2 lines, 12 lines, 6 lines, infinitely many lines? Okay, remember a line is defined to be the distance between 2 points that goes on forever, right? So when I'm talking about a line, I'm connecting any 2 points to draw that line. So would you agree I could have a line here? Okay. And then I'm going to connect maybe here. Is that a different line? Yeah. And then here. So now we're at least at 3. I could go here. That's 4. Do I have any more I could draw? Okay, so diagonally, these two would be a different line. There's 5. These two would be a different line. That's 6. Can I connect any other points? Where would I connect at, Ridley? And so it would be the same line, right? Depending on, yes. So it's still the same line. So 6 is the total number of lines. Be careful if you're counting arrows because each line has 2 arrows. So it might look like you have 12 lines when really you only have 6 because there's 2 arrows on one line. Does that make sense? Sometimes they're not going to be easy, so draw yourself a picture, investigate it, make up some examples, investigate them. But again, all you're doing is answering the question, so the answer would have just been 6 is all you'd have to put on your paper. Okay, complete the conjecture. The product of 2 odd numbers is blank. The product of 2 odd numbers is blank. Give me some odd numbers. And what does product mean, by the way? Product means not when you add, that's sum. Multiply. Product means what you get when you multiply. So give me 2 odd numbers. 3 and 5. Okay, 3 times 5 is 15. Give me some more odd numbers. 9 times 11 is 99. Couple other ones. 101. How about times 3? All right, let's not make it too hard. So be careful. Is 1 odd? Is the number 1 odd? Okay, what's the definition for odd? Is 1 prime? Okay, 1 is odd, but 1 is not prime. What does prime mean? Prime means you can divide it by itself and 1, but 1 is the number, so you cannot divide it by 2 other things, by itself and 1. When we talk about prime, it's just 3 and then numbers above it is not 1. 1 is not prime, okay? But 1 is odd. All right, what is my answer here? What is the product of 2 odd numbers? They're always odd, okay? Always odd. Again, if you don't know, make up some numbers, investigate. Okay, so can I see your notes really fast? Thank you. All right, we'll do this one. Read this, and you're going to try to make a conjecture, which means you're writing a sentence. I'll give you a couple minutes. Talk it out. Okay, so just make a conjecture based on the data. Just like Edwin walked in wearing a white shirt, wearing a white shirt, wearing a white shirt. I said, Edwin wears a white shirt every day. Okay? You're going to look at this data. You're going to write a statement based on that data. What is a conjecture that you could make? A valid conjecture. Something true. Okay, raise your hand if you have a conjecture. Go for it, Edwin. What's your conjecture?
Blue whale blows are going to be higher than the humpback.
Okay, so the blue whale blows are higher than humpback whales. If you look at the answer here, yes, there are multiple options, but this is exactly what Edwin just said. The height of a blue whale's blow is greater than the humpback whale's blow. You can make a conjecture. It does not have to be super specific. Notice here was another one that says the height of the blue whale's blow is about 3 times as great. So they got a little more specific and said it looks like that this is about 8 times 3, 7 times 3, 8 times 3, 9 times 3. Not quite, but close. And so they got a little more specific. You do not have to be super specific. What Edwin said is perfectly fine. Did anybody have a different conjecture? Okay, so don't make this super hard, but write a complete sentence if it says make a conjecture. So we've completed conjectures, we've written conjectures, we've reasoned and come up with the next item, and we've described the pattern. Are we good so far? Okay, so sometimes your conjecture is true and sometimes it is not true. To prove a conjecture true, you would have to prove it true for every single instance, or you would have to come up with one counterexample. The day that Edwin walks in wearing a different colored shirt than white disproves my conjecture that said Edwin wears a white shirt every day, right? If he wears a blue shirt tomorrow, it's like Lashley's conjecture was wrong. Okay, so to show a conjecture is always true, you have to prove it, which is where we're headed. We're going to write proofs. But today, we're not doing that. We are just going to show conjectures are false by trying to come up with one counterexample. Your counterexample must be specific. I'm going to write this. Be specific. I'm going to be super picky about that. So, for example, not specific would be an acute angle. Specific would be a 30-degree angle. Okay? Not specific would be any odd number. Specific would be 3. Okay? Be specific. You're looking for a counterexample, not a general broad topic, but a specific counterexample. And you only need one. The minute you come up with one, it is no longer true. Your counterexample could be a drawing, a statement, or a number. So it may be that you draw me a picture of a 30-degree angle. It may be that you write the measure of the angle is 30 degrees. So again, watch your time, so if you need to watch it, you can. Okay, here we go. Show that the counterexample is false by, show the conjecture is false by finding a counterexample. Remember, you're going to be specific, and this is where your algebra comes in. You've got to know what integers are. What's an integer? Positive and negative whole numbers, okay? So if you don't remember that, Google what is integer, so you'll know when you're doing your homework. These are things you'll need to know then when you get to the test, so make sure you do know. Integer means positive and negative whole numbers, okay? So it says for every integer n, first of all, let me tell you this. For your counterexample, it has to keep the first part of your conjecture true, so you can't pick a number that's not an integer. The first part has to be true, but you're coming up with something that makes the last part false. Okay? So you're trying to come up with a specific example that keeps the first part true, but makes the last part false. So for every integer n, so we're going to pick a number that is an integer and let it be our value for n. We want n cubed to not be positive, because this says n cubed is positive, and we want to prove that this is false. So we're going to come up with a counterexample. So can you think of a number that you could plug in for n that when you cube it is not positive?
Is there a way like you would not prove it wrong?
If it says find a counterexample, then that means there is a counterexample that you can prove. Okay, what is 3 cubed? Okay, is 27 positive? Positive versus negative. You're thinking even and odd, right? Okay, so this is still positive, so that won't work. Javi, a negative number. That's not going to work for an answer. Give me a specific negative number. Thank you. So you could say for your answer, n equals -3. That is your counterexample. Do not say any negative number. I will count it wrong. A counterexample is a specific example. You could plug it in and check it. -3 cubed means -3 times -3 times -3, which is what? -27, and that is not positive. But this is not your answer. This is your investigation. Your answer is n equals -3. You do not have to show that. Okay? All right, let's try another one. Say it again. Okay, because the definition for a counterexample keeps the first part true and the last part false. That's how you come up with a counterexample. You can't just pick anything because it said for every integer n. So when you're coming up with a counterexample, the first part of your statement still has to be true. In other words, Morgan can't walk in tomorrow wearing a blue shirt and me go, oh, that disproves my conjecture that Edwin wears a white shirt every day. Because my conjecture was about Edwin. That part still has to be true. Okay? But if Edwin walks in wearing a blue shirt, now that's a counterexample. Okay? It is. This chapter will be more like English. All right. Go ahead. See if you can do this one. You are coming up with a conjecture. This is your conjecture. You're coming up with a counterexample so that you can prove it is false. A counterexample proves the conjecture false. And you have to do that. You have to come up with a specific example that proves it false. C comes before S in the alphabet. 90 comes before 180, if that helps. Oh, yeah, sure. Okay, here we go. 2 complementary angles. That means this part still has to be true. You can't come up with more than 2, and they still have to be complementary. The last part needs to be false. So instead of not being congruent, we want them to be congruent. So you're trying to come up with an example where you have 2 complementary angles that are congruent. That means you could draw me a picture if you want. Complementary means that you have 2 angles that add to be 90, and you need them to be congruent. So you could say this is 45 and this is 45. They are congruent and they are complementary. Or you could just say 2 45-degree angles if you wanted to just write a statement. The picture would work as long as you indicate that those are both 45 degrees or that they are congruent and adding to be 90. Is this making sense, Tyler? Yes, you do need the box. Okay. Okay, we're going to try just a couple more. Show the conjecture is false by finding a counterexample. Again, it has to be a specific example. So look at the chart, read it, come up with a counterexample. Will not feel like Christmas there. Okay, the monthly high temperature in Abilene is never below 90 degrees for 2 months in a row. So again, the first part has to stay true. You have to still be talking about monthly high temperature in Abilene. You can't talk about a different city. But you want the last part to be false. So instead of it never being below 90 for 2 months in a row, you're trying to find an example where it is below 90 for 2 months in a row. Where does that occur?
January, February,
Exactly.
March,
Be
December.
careful. This December of 2019 does not match up with last January 2019, right? The next month is not the previous January. What's the next month? It's January 2020, right? So be careful. These months are not in a row. Does that make, because it's not the same calendar year, it doesn't circle around. So January and February would be your answer. If it's in the textbook, that won't work. You'd have to write January and February. If it was on a worksheet, you could circle those two. Yep. Okay, so it can be a picture, it can be a word statement, it can be numbers. You are just giving me a specific example.
So January, February.
That will work. And that's what they wrote, January and February. They wrote a long sentence, but you can just put January and February. Okay, last one we're going to do. Because I gave you the answer to the very bottom one already, because I forgot to delete the picture. So, it's there for you, okay? So we're going to do this one. Show that the conjecture is false again by finding a counterexample. So go ahead, see if you can come up with, first part has to be true, second part needs to be false. A specific example. Except it can't be imaginary. And if you haven't learned about imaginary numbers yet, no, for real, when you get to Algebra 2, you should have learned in Algebra 1 that you can't have a negative underneath the radical. That's called an imaginary number. So this will actually turn out to be I square roots of 2, and you'll talk about I and imaginary numbers in Algebra 2. So we don't have time to really go there. It's a lot of fun. You're going to have great times. It's so fun. But for now, just know it doesn't have anything to do with I, okay? I do. I didn't when I was in high school, though. Yeah. It was the hardest math for me when I was in high school. But we're going to get better. It's going to be awesome. It's not going to happen on the second test. I promise you. Okay. So we need to see, like... Yes. Okay. Do I have anybody with an answer? 0.3. 0.5. So what I'm hearing are decimals, and decimals are also fractions. So 0.3 is the same as saying 3/10, or 0.5 is the same as saying 1/2, right? Okay, so you're saying that if I plug in a fraction, but you do have to be specific, remember, don't put any fraction, be specific. But if I plug in a fraction, I'm going to stick with 1/2, 0.5, and I square it, I'm going to compare that to 1/2. And this says that this is always greater than or equal to this, right? We want that to be false, so we don't want it greater than or equal to. What is 1/2 squared? 1/4. Square the 1, you get 1. Square the 2, you get 4. Is 1/4 greater than or equal to 1/2? No, 1/4 of something is less than, so that means your answer of 0.5 or 1/2 would be correct. And so would 0.3 or 3/10. Any fraction would have worked. Would 1 work? No, because 1 squared is equal to 1. So that would not be a counterexample. Okay, do we understand counterexample? And understand that a conjecture is a sentence that you come up with by inductive reasoning based on a pattern. Okay, so now we're going to move to 2-2. 2-2. All right, this is where we start writing more sentences. And I'm going to try to go pretty quick, okay? To everybody, so you were missing the 2-2. I thought I didn't have any extra copies, but here you go. Okay, quickly. Lots of vocab here. I don't know, I'll have to look. Conditional statement. You guys with me? A conditional statement is a statement that can be written in the form, if something, then something. They're going to write P and Q because they don't want to have to write out super long sentences here for the examples. But an example would be, if it is raining, then the ground will be wet. I'll go with that. Okay, so if it is raining, then the ground will be wet. That is an if-then statement. That's a conditional statement. Conditional statements are written in the form, if something, then something. Okay? That something at the beginning, we're going to call our letter P, and the part at the end, we're going to call the letter Q, just so we can write it faster. Does everybody understand that we're just using that as a symbol? Okay, the hypothesis is the part P of the conditional statement. Here's the part I always end up counting off for. It follows the word if. It does not include the word if. So your hypothesis here is the part after the word if, but before the word then. So what is our hypothesis? It is raining. This is the hypothesis. Okay? Not if and not any of this. Just this. This is your hypothesis. Okay? Just the P. Your conclusion is the Q, which is the part that follows the word then. Again, it does not include the word then. So if they say identify the conclusion, you do not include the word then. It is just the part after the word then. So my part after is the ground will be wet. So that is your conclusion. Okay, so hypothesis is the P, conclusion is the Q, and it's if P, then Q. They are going to ask you to use symbols and arrow notation to identify these different statements we're going to learn. Conditional is our first one. So the way you can do it symbolically is to say P implies, that's what that little arrow means, P implies Q. It is raining implies the ground will be wet. Okay? Sometimes they're going to ask you to draw a Venn diagram. When you draw the Venn diagram, your conclusion is always the big circle. Your hypothesis is always the inside smaller circle. So you would, say it again? No, you will actually write the words. Okay? P and Q is just for the notes to make it quicker. So what we would do would be something like this. And then we would include whatever's in our problem, like raining, which is our hypothesis, and ground is wet, or wet ground. Okay? So inside is your hypothesis. If it's raining, then the ground is wet. Okay? So when you're talking about your Venn diagram, your hypothesis is the innermost circle, your conclusion is the outermost circle. All right, you can have true if-then statements. You can have false if-then statements. So your conditional may or may not be true, okay? For example, if you make a B, then you made a 87. Okay, if you made a B, then you made an 87. Is that true? No, if you made a B, you could have made an 86, an 85, an 84, 83. So it could be a false conditional statement, but if it's an if-then form, it is a conditional. Okay, so some simple ones here and then some not so simple ones there. Starting with the first one. If today is Thanksgiving Day, then today is Thursday. Identify the hypothesis. What is the hypothesis? Okay, not if. So on your homework, you would write out today is Thanksgiving Day, and that would be your hypothesis. Make sure and identify that it's the hypothesis. A lot of times students will do H and then write it out. Okay, and that works. Just don't write two things without telling me which one's which. Okay? And it says identify the conclusion. So C, what's your conclusion? And again, do not include the word then, so it's just today is Thursday. Okay? Hypothesis, conclusion. Pretty easy when it's in if-then form. But look what happens. Notice now this is not in if-then form, but it does still have what word in it? If. Find the word if. The part that comes after the word if is your hypothesis. So a number is a rational number if it is an integer. What's the hypothesis?
It's
Right. It is an integer is your hypothesis because it comes after the word if. There's not a word then, but if we were to rewrite this so that it was in if-then form, we would say if a number is an integer, then it is a rational number, right? So our conclusion here is going to be what? You could say a number is a rational number. You can say all of this. You just can't include the word then. But then is missing from our problem anyway. Okay? If we wanted to rewrite it so that it was an if-then form, here's where I will be picky. This is the English teacher part. You should never start a sentence with if it, if they, if them. Who's it, they, and them? Be specific. So I would not start this sentence with if it is. I would go back and identify my subject. If a number is an integer, then it is a rational number. When you start a sentence, always identify your subject. Does that make sense? Okay, so I'm going to be picky about that when you're writing your sentences. We'll practice, so no stress yet. Okay, this is just FYI. We are not going to worry about this, but some textbooks, as you get higher up, go into pre-cal, go into calculus, go into Cal 2, Cal 3. My son is now in differential equations at the U of A. He's went through Cal 1, 2, and 3. You're going to see lots of different things like this in your math textbooks. Not Brendan. No. That's Spencer. All right, so if P then Q, oops, let me go back. We are going to say if P then Q, we'll write it like this. We'll also use symbols and do this like we talked about. P implies Q. But you might see it in a book written as if P comma Q. We're not going to write it that way, but I just want you to recognize that's the same thing. They may say Q if P. That's kind of like that last example where it was the conclusion if the hypothesis. So we won't write it that way, but you might see it written that way. Again, the arrow means implies. So sometimes books will just put P implies Q. And then sometimes they'll write it as P only if Q. But what I want you to know is when we're doing our problems, we're only going to do this one as a sentence and then our symbolic notation. Okay? So no worries about the rest. Just if you see it in a textbook, they mean the same thing. That's notation. Means the same thing. Okay, so we already looked at this, but I do want to point this out. Many sentences without the words if and then can be written as conditionals. We looked at it when we had an if and no then, but we're getting ready to look at a problem where there's not an if or a then. You're going to write it as a conditional statement so that it is in the form if, then. Okay? So the way you do that is to first identify the subject, identify the sentences, hypothesis, and conclusion by figuring out which part depends on the other. Okay? Which part of your statement depends on the other. So you're going to try to write your sentence, figure out what your subject is, and then identify what's your hypothesis and your conclusion. Okay, so for example, write a conditional statement for the following or from the following. An obtuse triangle has exactly one obtuse angle. Okay, so here's what I usually say. Identify your subject. What is the subject of this sentence? Okay, an obtuse triangle. All right, so that's what we're talking about, an obtuse triangle, and the obtuse triangle has exactly one obtuse angle, right? So this obtuse triangle would be our hypothesis, and the conclusion would be, if it's obtuse, it's going to have exactly one obtuse angle, right? Okay, so what we want to do is be able to write that in if-then form. And the hardest part for students is the first part. What I usually recommend is when you start with your word if, and you've picked out your subject, you need to come up with a more broad word for it. So an obtuse triangle is a type of what? Shape or triangle. You could use either word, it doesn't matter. So you could say if a shape is an obtuse triangle. Or you could say if a triangle is an obtuse triangle. You need to come up with something more broad to make your sentence work, okay? So if a shape is an obtuse triangle, or if a triangle is an obtuse triangle, then make sure you include those key words. Then what? Okay, then it has exactly one obtuse angle. And again, I'm going to step it up a little bit when I'm grading your papers. Make sure you're starting with the capital letter, ending with punctuation, that it's grammatically correct. So these sentences you need to be extra cautious on in this chapter because it's a little different, okay? Are you guys with me? So what if we said something like, a blue jay flies in the sky? Exactly. Way to go, Tyler. Good job, Javi. So notice we started with the subject was blue jay, and then we came up with a more broad word for blue jay. It's a bird. You could have said it's an animal. Just be more broad, okay? Is that making sense? Okay, we're going to stop there for today. So here's the deal. What do we have left? We haven't gotten into any of the major stuff. Okay. Okay, guys, listen up real quick, please. You have enough information to do all of the first page. You might be able to do some of the second page, but because we didn't finish, this will not be due on Thursday. We'll make it due on Friday, okay? So at the top of this, but here's what we are going to do. We're going to get through 2-4 tomorrow. So we're going to rush. We're going to get in here. We're going to get after it. We're going to get through it. So that means the homework you get tomorrow is also going to be due on Friday. Okay? So do as much of this as you can, but don't try to do the stuff you don't understand.